Hello students, welcome to SP classes of class 10. Let's see our next exercise, that is exercise 1.3. In this exercise they have given only 3 questions we are having. So first one, prove that root 5 is irrational. What they have given? In this chapter, in this question they have given about rational numbers and irrational number. This type question we solved in our 9th class also. See here, any prime number is divides, let p be a prime number. If p divides a square, then p also divides a, where a is a positive integer. So they are talking, if any number, prime number is divides with a square, then it also divides with a also. So now let's prove our first question. See this, we can prove this root 5 is irrational. For this we can prove by contradiction method. So first take prove by. In this we have to write completely theory type part only, because this is the theorem and we have to prove this one. Already in our example they have given, show that root 3 root 2 is irrational, root 5 minus root 3 is irrational, and prove that root 3 is irrational. Like that, say they have given root 2 is irrational. They have given many examples. According to that only, here they have given one root 5 is irrational. So we can solve this with contradiction, because root 5 is irrational. Already we know that. So but we have to take this one as opposite type. Let root 5 is a rational number, because contradiction type we are taking, so instead of irrational we are taking rational number. Root 5 is equal to p by q, because rational numbers where q is not equal to 0, and p and q do not have any factor except 1. Here p and q do not have any common factor. Here you take any common factor except 1. This is the statement A. Let's take this one statement as A. So therefore root 5 is equal to, take this one as divide this one, root 5 into q is equal to p. Therefore root 5 into q whole square is equal to p square, by squaring on both sides. Okay. After this, again how we can solve this one? Take p square is equal to 5 into q square. Instead of this root we removed as with square. So this will be one part. For this take a equation 1. Now next, therefore 5 is a prime factor of p square by theorem 1.3, where we seen p is the p square by theorem 1.3 we have to write here, like how we seen here, where p is a prime number, p divides a square and p divides a also, like that type. So 5 and 5 square both also divides with p square. Now next, 5 is also factor of p. According to that theorem only we are taking this part also. So now let's take this as statement B. Now next, let p is equal to 5m, that is equation 2. How we take here, we took here m means instead of this q square, m is equal to q square we taken here, that's it. Put P is equal to 5m in equation 1. Now 5m square is equal to 5 into q square. Therefore 25 into m square, because this 5 square means 25 we are getting, 5 into q square. 5 ones are 5 5s are. So here it will be 5m square is equal to q square. Okay. Here 5 is a factor of q square and also 5 is also a factor of q square. This is our statement C. So we got here statement A, statement B and statement C. After this, let's see, by seeing all these statements, what we have getting, statement B and statement C contradicts with statement A. This B and C, these both are contradiction with statement A, because P and Q do not have any common factor. But here what we are having, we are getting 5 as a prime number in the both the places. So statements B and C contradicts statement A. Our assumption is wrong. So we are assumed and we have taken this as by contradiction. So our assumption was become wrong. Our assumption was wrong. Root 5 is not a rational number. Therefore root 5 is an irrational number. Hence proved. Hence we proved this root 5 is a irrational number. I hope you all understood. Thank you.